Okay, so for m, we have 0 to infinity. O yan, nag-start na tayo maggamit ng infinity, no? Then we have 1 over a squared plus b squared x squared. Okay, so dito walang sinabi kung ano ba yung ating a and b. So we assume that this is a constant, knowing na ang ating variable of integration is just x. Okay, so if we try to substitute yung ating values na 0 dun sa ating x, so meron naman tayong sagot dito, no? 1 over a squared is still considered an answer. How about if we try to increase the value of your x, let's say from 1, 2, 3, 4, 5. So basically, meron naman tayong sagot dyan. Even if it's negative, makakuha pa rin tayo ng sagot dyan kasi you have to square that value. So basically, positive yung makukuha mo lagi. So in short, pwede natin siyang integrate, but how do we integrate this kind of stuff? So ang gagawin natin ngayon is ipapattern natin siya dun sa mga fitting integrand na we can do. So I'll be trying to factor out b squared in this expression. So that is 0 to infinity and then 1 over b squared, and then this becomes a squared over b squared plus x squared dx. So ba't ko kaya ginawa yan? So I did that because I want to factor this out dun sa mismong labas ng ating integration procedure. So we have 1 over b squared kasi I want to show you na this expression looks exactly like an inverse tangent expression wherein we have a over b as your constant. So, diba, ganyan siya. So, with this, the antiderivative of this expression is equal to the inverse tangent of x over a over b. So, that is x over a over b. So, that becomes bx over a. Okay? And then, remember, you have to take this constant here, 1 over b squared, and then multiply this by 1 over a. In this case, your a is actually the square root of a squared over b squared, so that becomes b over a. Okay? So, hopefully, nakasunod kayo dun sa ating ginawa dito, no? Basta, this is your constant. And remember, kung meron kayong constant, so you have to take the square root of that, and then you have to take the reciprocal of that constant. So, this becomes b over a. Okay? And then this is evaluated from 0 to infinity. Okay, now let us simplify muna siguro. So we have 1 over AB and then inverse tangent of BX over A. Okay, and then finally I can substitute the values now. So if we have 1 over AB, I can factor this out sa buong expression. No? And then we have the inverse tangent of, now if it's BX to infinity, so we know that this is inverse tangent of infinity minus the inverse tangent of this one is 0, so we have 0. Now, paano ba natin to evaluate? So, yung ating second term dito, yung inverse tangent of 0, we could just simply say na this is 0. Kasi ano ba yung value nung iyong angle na magpapa-0 sa iyong tangent? Diba? Usually 0 yan. So, we take the first angle closest to positive x-axis, so that is 0. But how about this infinity? Now, remember, your tangent function, kung hindi kayo aware, you can always do your unit circle, no? This is 0, this is pi over 2. And remember, since yung tangent function is just the ratio of sine x and then cosine of x, so what is the value of your sine x and cosine of x that will make this tangent approach to infinity or make this infinity as it is? So, ano ba yung angle na yon? So, di ba alam naman natin na if this is a ratio of sine and cosine, so we could say that for every value that is 1 for sine, we could say na pag tinake natin yung 1 over 0, this is approaching to infinity. Though this is actually undefined, pero if we try to loop this at your graph, then you can graph this from the values of x from 0 to pi over 2, and then you could see na yung ating values dito sa ating expression is kind of going to that pi over 2, which is an asymptote. So, diba, this is infinity? Kasi if you take the area of that, then that is actually positive infinity. So, with this, you can say that the value for this expression is actually pi over 2. Okay? And then, you subtract 0 from this. So, therefore, your answer is pi over 2 AB in this number. Okay? So hopefully I made sense on that certain expression kasi this is kind of tricky when you don't know the idea of having a tangent. So, just remember, kapag nakakuha kayo ng infinity and then you take the inverse tangent of that infinity, so you have to expect na yung magiging sagot nyong angle is pi over 2 or 3 pi over 2. So, mga ano sila, mga pi over 2k angle sila. Now, if it's 0, then it is a multiple of pi. Okay? So, pwedeng 0, pi, 2 pi, 3 pi. Pero pag ano siya, infinity, then that is supposedly be, multiples of 1.55. I mean, 0.5 pi. Okay? So, I think that ends your M. Okay? So, but this doesn't end our discussion pa. So, we still have 1, 2, 3, 4. So, meron pa tayong 4. So, now let's head straight to letter N. And that is the integral from pi over 4 to pi over 2. And then the square root of 1 minus sine of 2x. Okay? Now, remember, the only restriction that we can have here is that if our 1 minus sine of 2x becomes less than 0, kasi if it's 0, then that's just okay. So with this, we can have sine of 2x, diba? Sine of 2x being, negative sine of 2x being less than negative 1, or this becomes sine of 2x greater than positive 1. So, pwede rin yan. So, in this case, our inequality is sine of 2x should be greater than greater than 1. Okay? Actually, pwede rin siyang pwede siyang equal din to 1. Now, kung ito lang yung magiging restriction natin para hindi maging true ang itong equation na to, then we can't find any value of x kasi alam naman natin na the maximum possible value of your sine, any equation that is represented as sine of any value here, di ba alam naman natin na the maximum value na pwede dyan is equal to positive 1. So therefore, at any case, kahit isolve ko yan, yung value ng x, it doesn't matter anyway. Kasi alam natin na if x is equal to pi over 4, then this becomes sine pi over 2, which is not greater than 1, but equal to 1. And that is actually the maximum possible value. Whatever your value here, kahit pa siya is negative, you will still get the same result na magiging plus lang to, as well as this one is still less than 1. So in that case, we could say na this function is existing at any value of x. So the domain, we can say that the domain is x such that x is an element of any real number. Kasi kahit ano talaga siya, pwede yan. So with this, we can actually integrate this sa pi over 4 to pi over 2. Okay? So again, I would like to emphasize that the reason for that is that the maximum value of any angle na you take the sine of that angle or cosine of that angle would be 1. And if it's 1 here, na dun mo siya isusubtract, then you have to expect na you would always get an exact value that is positive here, or less. The least value would be just 0. So again, pwede natin siyang integrate, and siguro ang isa pang explanation is that for every gantong expression, you cannot produce any value of x that will make this greater than 1. So that is very impossible. Na-prove natin siya kanina dun sa inverse sine of 4/3 na wala tayong sagot. So with this, we can say na we can just integrate this. Again, how do you integrate this? Wala tayong cosine of 2x. Now, what I'll do here is that I'll use the property of sine 2x. That is 1 minus 2 sine x and then cosine of x. So, what of it kung ginawa ko siyang ganon? Ano yung sense? No nga? Kasi, naglagdag lang ako ng cosine x. So, ano kaya mangyayari dito if I did something like this, no? So, what I'll be doing is that I'll represent this one in terms of cosine squared x and then sine squared x. So, diba yung ating 1 by Pythagorean theorem, we know that this is cosine squared x and then sine squared x. So, wala naman sigurong magdi-disagree sa akin doon kasi this is one of the easiest equality na kaya nating soluhin sa trigonometry, no? Now, remember, if we have this kind of expression, no, cosine squared x plus sine squared x, which is technically ito yung 1, okay? Yun yung 1. and then this one is from the sine 2x. We can actually rewrite this in a perfect square binomial that is the square root of, let's say, cosine x and then minus sine x, quantity squared. So how is this possible? So you can do sine x minus cosine x as well, no? Squared. It's just the same thing. So if you try to square this, diba, this is cosine squared x, and then minus 2 sine x cosine x. This is the middle term, and then you add the sine squared x. And this is also true for this expression. Kung inuna mo ngayon yung sine, it doesn't matter. It should be the same naman din. Okay, so dapat same lang din yan. Kasi if you try to evaluate this, same lang talaga sila. So, I can integrate this now siguro, no? Kasi if you'd be looking at this square and then radical sign, you can actually cancel them out, no? And how about this? Ano ba yun? Negative or positive? So, we just take the positive side of this. So, that will be cosine x minus sine x, or sine x minus cosine x. Kaya nga, di ba, if you try to do positive, negative, you will be getting cosine x minus sine x for positive, and then this exact expression at the right kung negative naman siya. So can you see the little subtleties na ginagawa natin dito, and they just arrive at the same results. So let's just use the positive one here, okay? And let's just prove later na doesn't matter anyway. So we have the value. So I think write na natin na final yung ating integrand. So that is cosine x dx minus sine x dx. Okay? And then this one is very easy to integrate na. So for the first expression, we have something like sine x. Okay? And then for this one, we have sine x, and that is cosine of x. So that becomes positive cosine of x. Evaluated from pi over 4 to pi over 2. Now, if you do this for sine x minus cosine x, diba? What is the derivative of your sine x? That is actually negative cosine of x, and this one is negative sine x. So the negative portion here would be ilalagay natin siya sa labas. So negative of sine x plus cosine of x. So if you try to substitute the values from this expression, so we know that is sine pi over 2 plus cosine pi over 2, and then minus cosine pi over 4 plus cosine pi over 4. Okay? So this is equal to, this one is 1, this one is 0, so to 0. Bakit cosine to parehas? This is sine. Okay, so sine. So this is 0, and then sine pi over 4, square root of 2 over 2. Okay? And then plus square root of 2 over 2 for this pi over 4. So tandaan natin, itong angle na pi over 4, ito yung same sila na maging value, no? So with this, kung ito yung square root of 2 over 2, and this one is square root of 2 over 2, you can just take this as square root of 2, diba? So with this, yung sine pi over 2 is 1. So it becomes 1 minus square root of 2. Okay? So I hope that makes sense for this problem. That is 1 minus square root of 2. Assuming that we take the positive side of this equation. Now, how about if we try to take the value that is at the negative side of this? So, in this case, we will be having something like negative of this whole expression. So that is 1 minus square root of 2. So this is actually square root of 2 minus 1. So for this expression, we can have this value. So again, ano ba yung pipili natin sa sagot dyan? So if in a case-to-case basis like this, no, and then I can see it from the process na negative yung sagot mo, pero it's still okay kasi that's the result of your integration procedure. So these two answers would just be correct. Usually kapag ang magnitude mo is the same and then nag-iba lang tayo ng sign, it is something like may konting error lang dun sa integration procedure, but most probably the answer is still correct, or most of the time ay dun lang tayo nag-iba ng konti, siguro sa letting ng u, but the rest is just the same, and that I will consider it correct, especially when we have these radical signs na pwede mag-result into positive, negative values. Okay, so that's it, I think, for your for this number. So let's move forward na sa sa next one. Okay, so now let's have the next item, and you might be thinking na let's do conjugate for this case kasi it looks baka pwede siyang gamitan kasi mukhang pwede naman eh. Now, for this case, I will tell you na hindi natin pwedeng gamitan ito ng conjugate basta-basta. Kasi we have this e to the negative s, and this exponential function is kind of very tricky when we try to redefine this. And remember, when you have a negative exponent, you have to make sure na or this rational expression where you have a negative exponent of e, you have to make sure na dapat mag-exist yung derivative niya dun sa numerator. And well, for this case kasi, if you try to differentiate the denominator, meron naman tayong e to the negative s, but how about this 1? So we need to make sure na yung ating whole numerator should be something like in terms of exponential function, just to make sure na yung ating derivative is a pure function of our exponential function. So I hope na-guess nyo yung idea doon. So what I'll be doing in this case is that I'll be redefining this by multiplying this to e squared s. So in that way, I can have a value that is positive yung s, kasi actually mas madali siyang gamitin kaya ako gagawin siyang positive. And in the same way na magiging s na rin yung ating 1 dito in terms of exponential function. So with this becomes negative 2 to 2, and then e raised to 2s minus e raised to s, and then divided by something like e raised to 2s, and then plus e raised to s, and then ds. Now remember, if you have this expression, huwag kayong magka-cancel out kasi, for example, na-redefine mo and then finactor out mo yung e to the s kasi pwede siya. So parang bumalik ka lang dito, no? Hindi yun yung goal. Now, the next goal natin is to make sure na this is well represented in terms of e sa ating exponent, sa ating numerator. So with this, I'll be rewriting this in terms of e raised to s, and then e raised to 2s, e raised to s minus 1 ds, and then divided by e raised to 2s plus e raised to s. Okay, so with this, ano ba yung sense ba't ko ginawa itong ganito? Kasi I will let u equal to e raised to s. So with this, if I try to differentiate this becomes e raised to s and then ds. Now, this is the exact derivative of this expression. And then I can represent this e to the s na natira in terms of u. So this becomes negative 2 to 2, and then that is your u minus 1 du, and then divided by u squared plus u. Okay, so hopefully na-guess nyo kung bakit naging ganito na siya ngayon. So it's a lot easier to integrate this, no? So now I'll be separating these two terms. So we have negative 2 to 2, and then we have u du over u squared plus u, which in turn becomes, pwede natin cancelin yung u dito. Okay, so okay na yon kasi nasa ibang variable na tayo. So this becomes du over u plus 1. Okay, so yun yung ating first term. And then the second one would be minus du over u squared plus u. And remember, wala ka na pwedeng gawin dyan. Yan na yun. Hindi natin siya masisimplify. So the first term is a lot easier to integrate. So we can have this u plus 1. So remember, the integral of your u plus 1 extended natural logarithm. So that is u plus 1. Okay, so yun yung ating antiderivative. And then how about this one, du over u squared plus u? Now, kung tandaan nyo itong gantong expression, diba, this is u squared plus u. So kulang siya, hindi siya completed. So we complete the square, and then we use our inverse trig function. So with this, we have du over u squared plus u plus, this is 1/4 minus 1/4. And then this becomes du over u plus 1/2 squared minus 1/4, and then you can just use your inverse trigonometric function. Now for this case, since this is negative, you can use your hyperbolic tangent function. Just make sure na you have the negative sign. So in this case, this becomes positive kasi babalik rin natin tong expression na to in terms of negative du over 1/4 minus u plus 1/2 raised to the second power. So this becomes positive na, no? So positive 1 over a. So that is 1/4. So this becomes 1/2. Okay. And then the inverse hyperbolic tangent of your u over a. So that is u plus 1/2. So we have u plus 1/2 divided by 1/4. I mean 1/2. So that is 1/2. Okay. And we evaluate this from -2 to +2. Now, if you try to simplify this muna bago natin ibalik sa original equation, then we have 2 inverse tangent hyperbolic of we can actually redefine this or rewrite this in terms of 2u plus 1, and then this becomes 4u plus 2. So hopefully follow nyo yung nangyari dito. So diba this is something like 2. So actually pwede palang na lang. Hindi pala 4u plus 2 kundi lang 2u plus 1. Okay, so yun lang naman pala. And then from -2 to +2. So I'll be rewriting this in terms of e to the s, so that is ln of e to the s plus 1 plus 2 inverse hyperbolic tangent of 2 e to the s plus 1 evaluated from -2 to +2. So upon substitution to your original equation, then the answer should be something like this now. So that is ln of e raised to e squared plus 1 plus 2 inverse hyperbolic tangent of 2e squared plus 1, and then minus ln of e -2 plus 1 minus 2 inverse hyperbolic tangent of 2e raised to -2 plus 1. Okay, now we continue evaluating this. So kung ikakalculate nyo lang ito mismo, you will not be able to get an answer. But if you try to do this whole expression, ito kasama to, then you should be able to get a value that is equal to +2. Okay, so that is simply like 1 plus 1. So magiging 2 siya, and then -2. Okay, so ito naman, if you try to evaluate this expression and then adding this one, then you should be able to get a value that is 2. That's why if you have this 2 minus 2, then therefore the final answer for this expression becomes 0. Okay, so medyo mahaba, pero how did that happen? So ipapakita ko sa inyo ngayon kung ano nangyari doon, ba't naging 0. And remember, yung ating expression for your inverse hyperbolic tangent is actually equal to nabigay ko na to sa inyo dati sa diffcal. So if you have here x, so this is equal to 1/2 the natural logarithm of 1 plus x, and then you subtract 1/2 and then ln of 1 and then minus x. So this is the general expression of your inverse tangent of x. And now what I'll do is that since hindi siya kaya ng calculator, I'll try to express this in terms of this expression, itong ating 2 tangent h inverse at saka yung latter portion. So yung 2 ilalabas natin ngayon. So if we have 2 na dito, mawawala tong mga 1/2 dito kasi may 2 multipliers sila, both of them. So in this case, I have the ln of 1 plus x, so that is 1 plus 2e squared plus 1. So this becomes 2 plus 2e squared. Okay, so I hope malinaw yun. And then minus ln of 1 minus this 2e squared plus 1, so that becomes -2e squared. Okay, and then if you try to evaluate this further, so we can say na we have minus, so ito na yun, ito yung portion na ginagawa ko, so minus ln of 1 plus x, so that's 1 plus 2e squared, 2e raised to -2, so that is +2 plus 2e raised to -2, and then of course you subtract the natural logarithm of using this 1 minus x, so that is 1 minus this expression, so that becomes -2e raised to -2. Okay, so with this, paano ba natin siya i-evaluate? So ito, pwedeng i-simplify natin further. Diba this this expression, pwede natin siyang gamitan ng properties. So if I do it here, this ln of 2 plus 2e squared and then 2 plus 2e squared, so mapansin nyo, this can be something like the natural logarithm of 2 plus 2e squared and then divided by 2 plus 2e to negative 2 kasi they have a subtraction sign. Now, how about this one? So, kung ito is negative, this becomes positive na kasi minus minus. So, therefore, we have plus natural logarithm of negative 2e raised to negative 2 divided by negative 2e raised to, squared. So, if that's the case, then this expression, now you can actually evaluate this and the result is equal to 2. Okay, so 2 na yun, yung expression na yun. Now, about this one. Now, for the latter portion, you can also evaluate that. So, you'll be able to get, just type lang sa equation nyo, sa calculator. And then, you can cancel out this negative 2 para mas simple yung isusulat nyo. So, e raised to negative 2 over e squared, that becomes negative 4. So, 2 minus 4 is equal to negative 2. So, hopefully, nag-guess nyo kung bakit siya naging negative 2 kanina. And how about this? Ln of e squared plus 1 and then this e raised to negative 2 plus 1. Remember, if you try to subtract these two, that is positive 2. So therefore, 2 minus 2 is equal to 0. That's why the answer for this is 0. So that's it for this problem. Now, I want to show you another solution why this expression became 0. So without doing integration. So, burahin din natin to. Okay. So, remember yung isa dun sa ating na-discuss ko about the handout. Now, we talk about odd and even functions. So, in this case, let's try to check if this is an odd or even function. Sinabi natin, pag odd function, if you try to take the negative of x, then you should be able to get the same result. So, this is even. Now, if it's odd, then if you take the negative of f of x, then you should be getting the exact negative of the whole expression. Let's try doing this. Let's try doing that in this expression. Now, since this expression is expressed in the negative exponent, I'll be rewriting this in terms of positive exponent. So, gagawin ko siyang ganyan. Kasi, di ba, pwede naman na siyang ilagay sa baba. Which gives you negative 2 to 2. And then e to the s minus 1 divided by e to the s plus 1, okay, ds. Now, if I try doing something like if s turns to negative s, what happens? So, in this case, I have the integral of e raised to negative s minus 1 over e raised to s negative s plus 1 ds, okay? So, can we actually compare this? So, hindi natin siya pwedeng pag-comparein kasi hindi naman pares yung form. So, what I'll be doing is that I'll be writing this in terms of positive s. So, 1 over e to the s minus 1 over 1 over e to the s plus 1, which gives me the negative 2 to 2, and then 1 minus e to the s all over 1 plus e to the s ds, okay? Now, this is the final form of negative s. This is your original. Now, let's try comparing this, no? So, if we have negative 2 to 2 and then 1 minus e to the s, 1 plus e to the s ds. So, to make this even, we should have the same value or result. So, but this one, hindi siya parehas, no? But if you try to take the negative of this f of x, this is your original expression. Now, if you try to take the negative of this original expression, will this be the negative of f of x? So, if you try to take this negative, so kung mannegative to, ang mapapalitan lang sa atin is basically yung numerator natin, mabaliktad lang yung kanilang symbol. And this is what happened. So, basically, we can say that this expression is an odd function. And knowing that this is an odd function, where you have a limit that is both lower limit negative x and then upper limit positive x, so or negative a, negative b, positive b. So if that is the case and your function or integrand is odd, then you should be getting a value that is 0. And of course, that is a case-to-case basis. It's not always happening in your certain integral expression. Just remember, it has to satisfy the two conditions, at least two conditions, that the integrand, when you try to substitute the negative variable on that certain integrand, yung result should be the whole negative of that certain original function, and then the limit should be the negative a to positive a. Hindi siya pwedeng magkaiba ng magnitude. Let's say negative yung isa pero negative 3, then yung isa positive naman pero 4. So, hindi yun pwede. Kailangan same sila ng magnitude, meaning same sila ng value, magkaiba lang ng sign. So, those are the two conditions na at least dapat masatisfy. Siyempre, given na yung mga conditions na dapat walang discontinuity, integrable siya. So, yun. That's the only way that we can do this odd and even functions. And pag hindi mo tanda, you can just perform the long method of integration. So, yun nga, kanina baka ma-encounter nyo is, ay baka hindi to pwede kasi nag-math error dun sa inverse tangent. So, make sure na you do your expanding if it's not possible for the calculator to evaluate it. Kasi, basically, kung calculator lang yan, and then naka-encounter siya ng the natural logarithm of a negative value, then hindi niya talaga na yung tutuloy. Pero you can always perform the properties, and then you might as well want to check if the properties are really giving you another value that will become positive on the latter portion of the solution. Okay, so I think we're down with the last two problems. So let's have letter B.